Now let's start talking about the internal combustion engines, and then this video we'll just have an overview of what IC engines are all about. Now IC engines, or you can say more importantly the reciprocating engine, it is basically a piston cylinder device. So this is a very common, or you can say a very familiar sight for any mechanical engineering student. Okay, so it's a piston cylinder device and it has a wide range of applications. So this part is called the cylinder. Okay, and this is your piston. Now the cylinder is the fixed part and the piston reciprocates inside this cylinder. So this is the kind of motion the piston will have inside the cylinder. Okay, now there are two fixed positions. The first fixed position is called a top dead center and the second one is called the bottom dead center. So this is the topmost, I can say, position of the piston in the cylinder, and this is the bottommost position of the piston in the cylinder, and the distance between the top dead center and the bottom dead center is called the stroke of the piston. Alright, now the cylinder is, it is circular in its cross section, so it should have a diameter, and the diameter of the cylinder is called the bore of the cylinder, or the bore. Okay, now there are two valves on top. Now this top is called the cylinder head. This is called the cylinder head. Now if you see that there is some you can say empty space between the top dead center and the cylinder head, this is called the clearance volume. This is the clearance volume, and if you have to give it a symbol or a denotation, you can say this is VC. Alright, and if you go from the top of the cylinder head to the you can say bottom dead center, okay, this would be the total volume. Alright, so the clearance volume is a part of the total volume, and the volume which is you can say traveled during the stroke of the piston is called the swept volume. So the volume, so if you talk about this is the swept volume. So you can say that total volume is equal to swept volume plus the clearance volume. Alright, now on top of the cylinder head you have two valves. One valve is the inlet valve and the other valve is the exhaust valve or the outlet valve, and in between the inlet and the exhaust valve you have a spark plug or a fuel injector depending on the kind of engine you have. Alright, so this is a very common schematic of any reciprocating internal combustion engine. And if you go down a bit, so this is the piston, this is the piston pin or the gudgeon pin, this is the connecting rod, or in short we can write con rod. Okay, and this is the crank, and this is the crankshaft. Right, so I hope it's a good refresher for all of you to have a look at this basic diagram of a reciprocating IC engine. Now the swept volume is also called the displacement volume. Let's give it another name. This is also called the displacement volume. Right, now let's come to a term which is called compression ratio. Now compression ratio is denoted by small r, and in parentheses you have K. Okay, so this is basically a ratio. Okay, so this is a ratio between two terms. Now what two terms? These two terms are the maximum volume upon the minimum volume. Alright, now this minimum volume over here, it is also known as the clearance volume, because if you look at this, this is the minimum volume that your working fluid can occupy within the cylinder. So this is the minimum volume. Okay, so the ratio between the maximum volume and the minimum volume is called the compression ratio. It is also known as the volume ratio. Okay, so it is also known as volume ratio. All right, now it should not be confused with the pressure ratio. So this is something that you need to note down. So this is not the same as the pressure ratio. Now another term which is frequently used in regard to the reciprocating engines is the mean effective pressure. So let's talk about mean effective pressure, or in short form we can write it down as MEP. MEP. Okay, now what is this MEP? Now it is basically, you can say, a hypothetical pressure, and it can be used or it can be calculated from the indicator diagram. So we will talk about the indicator diagram in the next video. So it is a pressure which comes out or which is calculated via an indicator diagram, and it is a theoretical pressure that if it acted on the piston during the entire power stroke would produce the same amount of net work as that produced during the actual cycle. Okay, so if you talk about the net work done by the reciprocating IC engine, so this is equal to the mean effective pressure into the piston area, all right. So this is now multiplied with the stroke of the piston. Now if you talk about area of piston into stroke of the piston, this is the displacement volume. So this becomes equal to the mean effective pressure into the displacement volume or the swept volume. Okay, so this is the net work. Now if you look at the relationship between, or if you look at this equation over here, okay, in this equation the total volume is the maximum volume that your working fluid can occupy, and VC is the minimum volume that the working fluid can occupy. So if you subtract the total volume minus the clearance volume, you would get the displacement volume. Okay, so let me rewrite this. So I can say that my total volume is the maximum volume, okay, and the clearance volume is the minimum volume. So I know that Vmax is equal to V displacement plus V minimum. So if I subtract these two values, I get V displacement. So the net work output is equal to MEP into the, I can say, maximum volume minus minimum volume. Alright, so if you have to find out the value of the mean effective pressure, then MEP is equal to the net work output divided by the change in volume or the swept volume, that is Vmax minus V minimum. So this is net volume or net work done upon the displacement volume. So this would be in kilopascals. Alright, so the mean effective pressure can be used as a parameter to compare the performance of reciprocating engines of equal size. The engine with the larger value of MEP will deliver more net work per cycle and thus will perform better. Alright, so in a nutshell, MEP is a comparison parameter. So this is a comparison parameter between engines of equal size. Okay, so this is where we use it and for the purpose. Now, the reciprocating engines, they are classified as the spark ignition engines. So if I write down the reciprocating engines over here, reciprocating engines. Now why I am specifically mentioning reciprocating, because if I just say internal combustion engines, then internal combustion engines can also be gas turbines, because in gas turbines the combustion is also taking place within a combustion chamber. So I will have to specifically use the word reciprocating over here. Okay. Now reciprocating engines can be used or can be classified into two types. So the first is the spark ignition engine, and the second one is the compression ignition engine, depending on how the combustion process in the cylinder is initiated. Now the SI engines is also called a petrol engine, and the CI engine is also known as the diesel engine. Alright. Now, this is a very common kind of a know-how that every mechanical engineering student has. So let's not go down that road, because it's very, very mundane, and I hope you understand, and I hope you all know about it. Alright. Now, in the next topic, I want to discuss about the air standard cycles. Okay. So the topic name is air standard cycles. Air standard cycles. Alright. Now, the internal combustion engines, in which the combustion of fuel occurs in the engine cylinder itself, they are non-cyclic heat engines. Okay. And the temperature due to the evolution of heat because of the combustion of fuel inside the cylinder is so high that the cylinder is cooled by water circulation around it to avoid rapid deterioration. Now, the working fluid, that is the fuel air mixture, it undergoes permanent chemical change due to the combustion, and the products of combustion after doing work are thrown out of the engine and a fresh charge is taken in. So the working fluid does not undergo a complete thermodynamic cycle. Alright. Now to simplify the analysis of IC engines, we make use of air standard cycles. So air standard cycles are conceived, and in an air standard cycle, a certain mass of air operates in a complete thermodynamic cycle, where heat is added and rejected with external heat reservoirs, and all the processes in this cycle are reversible. So it's basically, you can say, an idealization of the actual processes that are going on inside a reciprocating internal combustion engine, because in actuality the processes or the complete engine is non-cyclic. Alright, and to analyze it, we make use of the air standard cycles, wherein we take a certain mass of air and we make it complete a thermodynamic cycle, and all the processes are reversible. Alright, now air is assumed to behave as an ideal gas, and its specific heats are assumed to be constant. Okay, now the two most important air standard cycles that we are going to talk about in the next video. The first one is the Otto cycle. The second one would be the diesel cycle, and then we'll combine both of them to create a dual cycle. Alright, so this is what we are going to study in the next video onwards. So now let's move on to the next video and start our discussion on air standard cycles.